Hey everyone, in this video we'll learn all about exponential functions. So exponential functions are a type of function that are based on a percent increase or a percent decrease. So we have exponential growth. So exponential growth means there is a fixed percent increase. And on the other hand, we have exponential decay, which is based on a fixed percent decrease. So a common example where exponential functions are used are in a population of a town. So a population of a town may grow 5% each year. So we describe this as exponential growth. So if we draw a quick table with a year, so with the year here, and the population in this column, let's just scroll down a little bit. So let's say in year 1, the population of the town starts out at 100. Let's say this is all in millions. So this is 100 million, let's say, in year 1. Year 2, the population increases to 105. This is a 5% increase. Year 3, the population increases 5% again to 110.25. And then in year 4, the population again increases by 5% to 115.7625, roughly. But each year, the population increases by a fixed amount, 5%. And that's the key here. If there's a percent increase or a percent decrease with a fixed percentage, then we can describe this growth as exponential. This is exponential growth right here. And we can describe this exponential growth of the population of this town, we can represent it with a function right here. F of x equals, and we're going to use an exponential function, 100 times 1.05 to the power of x. And you'll notice that with exponential functions, the x, the dependent variable, the input, is in the exponent right here. So that's what makes a function exponential. If x is in the exponent, then it is an exponential function. And right here you can see, you might notice a few things about this function. First, we have this 100 right here, and 100 is what we started with. In year 1, we had a population of 100, so 100 was the base. That's what we started with. And then notice we increased by 5% each year. And where do we see a 5? Right here, 1.05. So 1.05. What is 1.05? Another way to write this is 1 plus 0.05. And what is 0.05? That's just 5%, or 5 over 100. So that's how we analyze this exponential function. F of x equals 100 times 1.05 to the power of x. And we can use this function to determine the population of this town in any year. All we have to do is input a year into x, and put it in this function, and we'll determine the population. So you'll notice exponential functions, all of them have this form. So the general form of exponential functions, f of x equals, they all take this form, a times b to the power of x. A times b to the power of x. So a can be any number as long as it's not 0. So a cannot be 0. And b must be a positive number greater than 1. So b must be greater than 1. So a cannot be 0, and b must be greater than 1. Because if b was less than 1, or let's say b was equal to 1, then 1 to the power of anything is still 1. So that wouldn't work. B has to be a number greater than 1. And what exactly does this describe here? So a is our base right here. So a right here is what we start with. This is our base. And this is also our start. This is the start of the function, the initial value. And b right here is growth. This is the growth rate. So all exponential functions take this form. And with the exponential function we saw above, our a was 100 right here, because we started with 100. That's our base. Our population started with 100 right here. And our growth rate was, our b is 1.05, 5%. 1 plus 5% right here. So that is the general form for every exponential function. And let's go ahead and actually take a look at this exponential function. F of x equals 2 to the power of x. So to the 2 to the power of x, let's actually just go ahead and graph it real quick. So right here, we'll draw a line, the y-axis, and the x-axis. So let's go ahead and just set up our graph. 1, 2, 3, 4, 5. -1, -2, -3, -4. 1, 2, 3, 4, 5. -1, -2, -3. Okay. So you'll notice that with exponential functions, they grow very, very quickly. So f of x equals 2 to the power of x. Let's just go ahead and input some values. What is f of 0? That's 2 to the power of 0, which is 1. So we'll plot that. First one right there, 0, 1. What about f of 1? F of 1 is 2 to the power of 1, which is 2. So 1, 2. And what about f of 2? It's 2 squared, which is 4. So 2 squared, which is 4. So that is 2, 4 up here. Okay, so you'll notice it grows very, very quickly in this direction. In fact, if we were to find 2 to the f of 3 is 2 to the power of 3, which is 8. That's much higher up. We'd need more space on our y-axis. But now let's go the other direction. What about f of -1? F of -1 equals 2 to the power of -1. And remember, negative exponents means that you flip it. This is 1 over 2 to the 1, which is 1 over 2, a half. That's -1 comma a half, which is right here. And then let's just do one more. F of -2 equals 2 to the power of -2, which is 1 over 2 squared. And then 2 squared is 4. So a fourth, which is even a little lower. So -2 comma a fourth right here. So let's go ahead and connect these. And you'll notice something very interesting about this exponential function, f of x. It never has a negative value. It never crosses the x-axis, and there is no negative y value for this exponential function. And that makes sense because any exponent, 2 to the power of any number, will never give you a negative number. It must always be a positive number. And also, it will never give you 0. In fact, you can see that this exponential function gets closer and closer and closer to 0 as we tend towards negative infinity in this direction, but it never actually reaches 0. And that actually makes our x-axis, an asymptote. So our x-axis is actually an asymptote. So asymptotes also exist with exponential functions as well. And let's go ahead and just take a look at the domain and range of this. So the domain of any exponential function is all real numbers, so negative infinity to infinity. And the range of this exponential function, f of x equals 2 to the x, well, we know that the smallest value it could be is, it can go from 0, but not including 0, because it will never actually equal 0, so we'll use a parentheses. And then the highest value, it can go all the way up to infinity up here. So from 0 to infinity. And then end parentheses. So that is the domain and range of this exponential function. And the domain for any exponential function is all real numbers. And the range depends on how you shift it. But as long as, if you have an unshifted exponential function, like we do here, it's not shifted up or down, then the range will simply be from 0 to infinity, not including 0. So I hope this video helps to understand exponential functions. If you have any questions at all, please leave them down in the comments below, and thank you for watching.